the game plan first. Hold up here. Here we go. Let's get into our notes. So what I want you to do is entitle your notes. Okay, entitle your notes functions intro. Functions intro. So put that on top of your notes. Take good notes because remember, on Friday's quiz, some of this vocabulary will be on the quiz, and if you have your notes, it's always open note, my quizzes. Okay? Functions intro. Now, before I get into what a function is, you've probably seen that before in your math pilgrimage or math career prior to Mr. Munguia. Before I even get into that, let me kind of talk about something else here. Okay. Look what I have in my hand here, or in my hands. I bought this for my grandson. I bought this for him on Christmas. And can anybody tell me what this is? What is this in my hand? Anybody?
It's a toy boat.
Okay, it's more than a boat, huh? This is not just any boat. Look at this anti-aircraft artillery right here.
Aircraft boat. I don't know.
One more time.
Yeah, I said aircraft boat.
Okay, aircraft carrier, that's it. Those are a lot bigger. Those are the ones that planes can land on. This is not as big as an aircraft carrier. I think someone said it. I could have swore I heard someone say what it is. Not just a boat, right?
Battleship.
Battleship.
It's a battleship. This puppy is a battleship. Now, this battleship is what we call a model. Okay, this is a model in my hand. The real thing is right in front of you on that picture there. And let me see if I already share it here. Hold up here. So the real thing is right in front of you on that picture there on my screen. That's a real battleship. This is just a model battleship. So your first vocabulary word I want you to write down is going to write the word model. Okay? A representation of a real thing that isn't the real thing. So all I have right here is a representation of the real battleship that's floating around the Atlantic Ocean or the Pacific Ocean, protecting our country. So I'm going to write down the word model, a representation of a real thing that isn't the real thing. I love that battleship, man. I think it's cool. So, a representation of a real thing that isn't a real thing. Okay. A representation of a real thing that isn't the real thing. Now, again, the title of today's notes is Functions Intro. I'm not sure if you're able to see this, by the way. I think I didn't post it here. So that's the title. Put this on top of your notes, Functions Intro. The first word is model. Not like a supermodel girl that guys gawk at and women want to be. A model is a representation of a real thing that isn't the real thing. Okay? So it's a different definition than like a supermodel. So far, so good. Here we go. Second word is phenomena. An observable fact, here we go. An observable fact or event. I'm going to write that. So you got two vocabulary words today. Two vocabulary words and then a big idea that we're going to put with a star right now. An observable fact or event. Anything that you perceive with your five senses is a phenomena. Okay? So right now, you looking at your screen and and hearing Mr. Munguia speak through my microphone coming out of your speakers, that's a phenomena. That's an event that's occurring, and you're seeing it with your five senses. Anything can be a phenomena, okay? Anything that you can observe with your five senses, taste, touch, hearing, smell, and seeing, right? Taste, touch, hearing, smell, seeing. If you perceive it with your five senses, that thing is a phenomena. No matter how trivial and silly it is or important it is, a phenomena is just something that we perceive in reality. Now, here's the big idea. Here's the big idea of me setting you up, all this with all the factory methods and this and that and that and this. Munguia has been setting you up for this. Here we go. Here's the big idea now. Go write this down with a big fat star on your notes. So you have two vocabulary words and then a big star. The big idea about functions. Functions can model real life phenomena. When a function models a real life phenomena, it gives us predictive power. We can predict the future. If we can create a function, and I haven't even defined what a function is. You've probably seen it before, and I'm assuming you've seen the word before in your math classes before me, but we're going to get into what a definition of a function is shortly. But functions in math model real life situations. That's the whole point. That's why before we slap a cap and gown on you and you graduate from Pomona Unified and
Why
educate.
is it so damn cold?
What happened?
Oh.
So part of being an educated person is knowing that, hey, you know what, there's these things out there called equations and functions, and they can actually model real life phenomena in reality. That's part of being an educated person, just knowing that. Now, you may not get into engineering and mathematics or sciences, but just being aware of that is good. It's part of being an educated person. That's why this is why Math 3 is required before we slap a cap and gown on you and give you a diploma. A lot of you are not going to get into sciences and engineering. You're not going to deal with functions in real life, but you need to know that they're out there and that they're an important part of life. Just like when you take poetry in English, you're not going to use poetry in the job, but an educated person should know something about poetry. An educated person should know something about literature. It enriches your life. Okay? Being aware of the world around you enriches your life. And if you're an enriched person, you're going to be a better contributing person to society. That's the whole point of education. A lot of you think that this is job. I'm training you for a job later on. I'm not training you for a job. Your history teacher's not training you for a job. You're not going to use the fact of Bolshevik Revolution or the American Revolution. That's not for a job. That's to be an educated person, to be aware of what's going on. That's the whole point of education. Same thing here. You need to know that, hey, you know what? There's these things called functions in math, and they describe real life phenomena. Okay, just knowing that is important for mathematics. Some of you are going to pursue mathematics and sciences. I don't know. Maybe you will. I don't know. But you need to know that, hey, you know what? In the real life, in the real world, all of our technology, there's functions behind all of that. There's mathematical equations that are involved in the production of things, from my smartphone to satellites, to battleships, to missiles, to computer programs, all this. There's functions that model the phenomena around us. That's the big idea of mathematics. Okay, that's why I've been teaching you all these factoring methods. Now, let me show you a real life phenomenon that's kind of funny and silly at the same time. Okay, so what is it? Let's take up the phenomena of a thug. A thug from Pomona. And there he is. You see the thug right there. Okay, there's a Pomona thug, a cartoon of him. And the phenomena in question right now is he's stealing an old lady's purse. So picture yourself on the corner of, let's say, 2nd Street and Gary. I don't know. Okay. Picture yourself on the corner of Gary and 2nd Street, downtown Pomona, and there's a crime scene. So let me go ahead and write crime scene here. Now, pay attention because I'm going to give you a free assignment pass if you can help the cop catch the thug shortly. But you're not going to be able to you're not going to be able to help the cop find the thug if you're not paying attention. So the crime scene is right here. So I'm going to allow the crime scene to be right where the, let me put an arrow here. There you go. And yeah, hang tight. Oh, and that put right there. Okay, cool. Now, so you're on the corner of 2nd Street and Gary. The phenomena, remember, phenomena is anything you can perceive with your 5 senses. You see a thug steal an old lady's purse and start running away after he steals it. Because, you know, that's what thugs do. They're cowards and they mooch off people and they don't contribute to society. They just take from people who contribute to society. So he's stealing an old lady's purse and he runs away from a cop at the rate of 4 feet per second. Okay, so this is a phenomena. You got a thug stealing an old lady's purse, you got a cop that sees it at the crime scene, and he starts chasing the thug. It's a phenomena. It's going on. It's observable. Our 5 senses see a thug running away. He steals old lady and he's running away. What we can do is we can actually form an equation to model. There's a word model now. We can form an equation to model the thug running away. Remember the battleship model. So the equation can model the thug running away. Watch this. So I have an axis. You've seen this before from Math 1 in junior high. You have a y-axis and an x-axis. But here, the y-axis here represents feet. Okay? This axis. Now, the word axis is just a fancy schmancy word for a number line. Okay? And the x-axis is going to represent seconds. So what I'm going to do is I'm going to create an equation that models the thug running away from the old lady. Now, what I want you to do on your notes is just go ahead and write this example. I'll give you about 10 seconds just to write, after stealing an old lady's purse, a thug ran away from a cop at a rate of 4 feet per second. And go ahead and just do a simple feet and seconds axis for me, okay? I'll give you about 30 seconds to a minute. Go ahead and copy this down, what you see on the screen, please. So if you want a free assignment pass, pay close attention. Now, so the crime scene's right here at 0, 0. Okay? The thug starts running away at 4 feet per second. So 1, 2, 3, 4 feet at 1 second. Okay, there it is. There's that first. After the first second, he's 4 feet away from the crime scene. Okay? After 1 second, he's 4 feet away from the crime scene. Okay, after 2 seconds, he's going to be 1, 2, 3, 4. He's going to be 8 feet away from the crime scene. Okay? So look what I'm doing here. I'm drawing a line here. So the word line, the word linear has the word line in it. So if I were to write linear here, a linear equation can model, notice the word I'm using, model. A linear equation can model the thug running away. Okay? A linear equation can model the thug running away. And that linear equation has to have feet in it. Let's put a variable for feet. How about F? And that equation has to have an S in it. We'll just, S would be for seconds here, okay? So there's two variables in the phenomena. The phenomena of the thug running away, there's two variables we're trying to track, seconds and feet. I mean, we see the guy, he's got tattoos and stuff, but the two variables of the phenomena that we're looking at, that we're kind of zooming in on, is seconds and feet of the thug running away from the crime scene. What I'm going to do is ask if someone can come up with the equation that relates feet and seconds of the thug running away. I'll give you guys about a minute. Now remember, what's going on here is the phenomena that's being modeled is a thug running away. Okay, but we haven't modeled it yet. We have to come up with the equation that models it. Okay, so I'm gonna give you about a minute. Let me know if you have an answer. What would be an equation that models feet and seconds of this thug running away?